Now, let's consider a case where I have 20 volts. And let's say that the capacitors that I have are only capable, they have some capacity. So capacitance equals, 40 microfarads. I'll just use the same ones I did before. 20 microfarads and 80 microfarads. Let's say those are capacitors 1, 2, and 3. But that these capacitors are made in such a way that if you put 20 volts across one capacitor, then that capacitor will not be able to handle it. It'll break down. It will arc across, and then we'll have a ruined capacitor. It won't do what we're wanting it to do. So in that event where you have that kind of situation, let's say these are all maximum 10 volts. We can't put them in there and put them in parallel, because if we do, each one of them is going to see positive 20 on this side and 0 on the other side. That's a difference of 20. And if they're only good for 10 volts, we can't do that with them. It turns out that if we have this situation, we can put them instead in what's called series configuration. So instead of putting them in parallel, we can put them like this. Now in that configuration, what's happening? We look at this, okay, we start here, positive charge comes here, comes up here, gets to this point, has to stop. Meanwhile, in between here is neutral. But it's neutral, and then it sees this positive show up here, and so a negative charge comes over to this side. Actually, I'm going to blow this whole thing up, draw it a little bit bigger here. That just look like a bunch of H's together. I don't want that. So positive charge shows up here, and in between is neutral to start with, but once I see a positive charge show up here, a negative charge comes over here to be close to this. And when that negative charge comes over here, of course this side has more positive charges than negative charges. But when this positive shows up here, in between here, which is neutral, a negative charge runs over here, which leaves a positive behind. And there's plenty of negative charges over here on the negative side of this battery, so a negative charge shows up here. So unlike in the case where they were in parallel, where a single charge came up and then had to make a choice, am I going to the first capacitor, second capacitor, third capacitor? Now a single charge comes up, it's there. And the same amount of charges are on each capacitor. So if 5 charges come up here, there's going to be 5 negatives that show up over here, which is going to leave behind 5 positives over here, which is going to create 5 negatives over here, which is going to leave behind 5 positives over here, and bring 5 negatives up here. So in the case where you are in series, Q1 equals Q2 equals Q3 equals the total charge. Okay, whatever charges come out, that same amount of charges on each one of these. Now what does that mean from the perspective of determining what the total capacitance is? It's not going to be like this, because over here, these are all equal to each other. So Q1, well that's C1 times delta V. That's equal to C2 times delta V. I'll say delta V1, delta V2. And that's equal to C3 times delta V3.